Hey everyone, and welcome to The Explainer. I'm your host, and today we're going to completely level up your troubleshooting toolkit. If you've ever been the on-call engineer at 2 a.m., staring at a massive wall of scrolling text with blurry eyes, desperately trying to figure out why the payment gateway is failing, well, you know that finding the right logline is basically like finding a needle in a massive digital haystack. Today, we're conquering LogQL, the query language for Grafana Loki. It is an absolute must-have skill for modern IT support, and by the end of this session, you'll be equipped with 5 foundational queries that will literally change how you debug forever. Let's dive in. But before we even type a single line of code, we've got to establish our core philosophy. Consider this your new mantra: filter early. You should always apply simple text line filters before you trigger expensive computational operations, like JSON parsing. Keep this principle right at the front of your mind, because it is the ultimate secret to reducing processing overhead and getting your query results back lightning fast. So here's our roadmap for today. We'll start with why LogQL matters, then hit foundation filters, regex keyword search, parsing JSON logs, and error rate metrics, before wrapping it all up with a real-world scenario dealing with intermittent 500 errors. Let's kick things right off with Section 1, why LogQL matters, focusing on its metadata-first approach. Traditional log platforms, they index the entire full text of every single log line. That means massive storage costs and, inevitably, super slow queries when you're searching through petabytes of raw data. Loki, on the other hand, takes a metadata-first approach. It only indexes the labels attached to your log streams, things like your environment, the app name, or the cluster. The actual log text, that's just compressed and stored in cheap object storage, like S3. Because the indexes are remarkably tiny, queries are blazingly fast and incredibly cost-effective. But to unlock that speed, you've got to know how to query it correctly. Moving right along to Section 2, Foundation Filters. We're looking at Query 1, which is all about stream selectors. Everything in LogQL begins with grabbing the right log stream using curly braces. If you just query a broad namespace, like namespace equals prod, you're basically asking Loki to scan millions of noisy lines across every single app in production. Good luck with that. But by adding just one additional label, like app equals payment gateway, you immediately drop the noise and isolate a clean, targeted stream. Precision right here is your absolute best optimization tool. By combining labels, you drastically narrow down the search space before the system even looks at the log text. Now, the really cool part is the flexibility you get with these label matching operators. You aren't just limited to exact matches using the standard equal sign. You can easily exclude things using exclamation equals, which is perfect for filtering out noise, like, quote, environment equals not staging. Or you can step it up and use equals tilde for a regex match, say if you want to target all applications that start with auth-tash. Mastering these 4 operators is step 1 to isolating your specific stream. That brings us to Section 3, Regex Keyword Search. Here's Query 2, where we actually find the errors. To do this, we use what's called a line filter expression. Once you've got your stream locked in those curly braces, you literally just use a pipe symbol to search the log content. If you're familiar with Linux, this functions exactly like a Unix pipeline. It takes the stream's output and pipes it right into a search. A pipe equals searches for exact strings, while a pipe tilde lets you search using regular expressions. This is where we aggressively sift through the data we just pulled. Let's look closely at this specific query. We've selected the payment gateway app, and then we use that pipe tilde regex operator. Notice the QI right at the beginning? That is an amazing pro tip, because it makes our entire search case insensitive. With one simple, elegant query, we're instantly catching logs that say error, failed, or timeout, whether they're fully capitalized, lowercase, or a mix of both. You're successfully catching multiple failure states in one single go without running 3 expensive queries. How great is that? Time to level up. Section 4, Parsing JSON Logs. This is Query 3, Structuring the Unstructured. Modern apps almost always log in JSON, right? So let's see how this builds incrementally. And remember, our golden rule: filter early. Step 1, select the stream. App equals cart. Step 2, apply a basic text line filter. IRO equals error. We deliberately do this before Step 3, which is adding the IRO JSON parser. Parsing JSON is computationally heavy. By aggressively filtering for the word error first, we might reduce 1,000,000 log lines down to just 1,000. Then we only parse those 1,000 lines. Finally, in Step 4, we filter against the newly parsed JSON fields, like status code equals 500. Here's exactly what that JSON parser is doing behind the scenes. It literally takes raw, static text properties, like a standard JSON string, and dynamically extracts them into native LogQL labels. Once your data is transformed from a flat text string into extracted labels, the real magic happens. You can query them mathematically, filter them by value, or even group your results by them. It completely unlocks your data. And boom, here is our beautifully refined query 3. App equals cart, L equals error, JSON status equals 500. It's elegant, it is highly efficient, and it outputs a perfectly clean stream of only the exact HTTP 500 errors coming from the cart service. This is exactly the kind of precision query you want to type into a Grafana Play sandbox when you're hunting down a stubborn bug. Moving right along to Section 5, Error Rate Metrics. Query 4 takes us from plain logs to SLO alerts. So in LogQL, you aren't just limited to reading text on a screen. A metric query lets you wrap your log query in a mathematical function. Functions like rate or count over time calculate time series metrics right on the fly. This is a massive benefit because it means you can generate powerful, actionable metrics without needing your busy developers to instrument custom metric code directly into the app. Your logs themselves are the data source. Okay, let's deconstruct this beast of a query, nice and slow. We want to find the percentage of errors compared to total requests over the last 5 minutes. On the first half of the division, we calculate the sum of the rate of logs specifically containing the word error. Then we divide that number by the sum of the rate of all logs for the payment app generated in that exact same 5-minute window. Finally, multiply the whole thing by 100, and you've got an exact, dynamic error percentage. And the result? A clean metric, like 1.5%. Now, why is this such a big deal? Because, as our sources point out, alerting on an absolute count, like, hey, alert me if there are 100 errors, is actually a pretty terrible practice. Think about it. 100 errors during a quiet midnight lull, that's a total catastrophe. But 100 errors during a massive Black Friday traffic spike, that's perfectly normal. Alerting on a 1.5% error rate, however, is directly tied to your service level objectives, or SLOs. It remains totally meaningful and highly actionable no matter what your traffic volume looks like.
All right, we made it to Section 6, the intermittent 500 scenario. This is a real support scenario.
Let's put all these tools together for a final boss battle. Picture this. You're the on-call engineer, your coffee is getting cold, and a critical ticket drops. It reads, user reports intermittent 500 errors during checkout at 10:30 a.m. You load up your Grafana Explorer dashboard. Where do you even begin? You definitely don't want to just stare at a wall of text hoping to get lucky. We're going to build the perfect troubleshooting query live right now. Here is the exact punchy checklist a senior engineer uses. Step 1, isolate the app with stream selectors. Namespace equals prod app equals checkout. Step 2, filter down to the exact errors. =sign 500. Step 3, parse the data to extract structured fields, JSON. And step 4, extract specific value targets. Here, we specifically filter for logs that actually contain a trace ID. Trace ID not equal to empty. But honestly, we can make this even better. Even after aggressive filtering, raw JSON can still be incredibly bulky and difficult to scan quickly during an incident. By appending a line format expression, like byline format trace, single quotes to trace ID, double brackets, trace ID, single quotes, and a double quotes, you completely rewrite the output. It takes the mess and cleans it up into a perfectly readable, customized checklist showing exactly the trace ID and the specific error message. It's beautiful and it's highly efficient. So why did we hunt so hard for that specific trace ID? Well, our sources put it perfectly. Correlating a log error to its exact trace is the single practice that most reduces investigation time. Distributed tracing is the ultimate goal here. By extracting that trace ID, you can seamlessly jump from Loki directly into Grafana Tempo to view the distributed trace. You immediately move from just knowing that an error happened to seeing exactly why and where it happened across all your microservices. We've covered a lot today. Isolating streams, regex searching, JSON parsing, generating error rate metrics, and building a live incident response query. You've got the professional toolkit now. So here's the real question. Next time you get paged at 2 a.m., are you going to waste an hour hopelessly scrolling through an endless wall of text? Or are you going to find the exact root cause in 60 seconds with LogQL? The choice is entirely yours. I highly encourage you to jump into the Grafana Play sandbox at play.grafana.com today and test these 5 queries out for yourself. Thank you so much for joining me on this explainer, and happy querying.